Primary financial and production support for Earthlings 2.0 comes from Technica Communications, an award-winning PR firm amplifying breakthrough technologies of the future. Additional support comes from Fourth Power, whose flexible duration energy storage system is purpose-built for peak demand, delivering reliable, on-demand, low-cost power with storage durations that cover the multi-day peaks that lithium-ion can't reach. And if you'd like to support the show, follow us wherever you listen to your podcast, or if you're watching this on YouTube, subscribe to our channel.
That's why it matters. Not only are we saving money on the input of energy cost, but we're eliminating landfill impact, and we're upcycling these opportunities into something that can be used for creation of superfoods or even sustainable aviation fuels.
Greetings, Earthlings, and welcome back to Earthlings 2.0, the show where we imagine how it can be better versions of ourselves and build a collective future that we actually want to live in. So today's side mission is about something that's hidden from most of us: waste management. It's a very important issue that impacts our everyday lives, impacts soft costs on businesses, and overall is just something that can be very harmful for the environment, as the traditional process is linked to fossil fuel combustion. In fact, latest numbers from the EPA, it's really going to depend on which report you see. It says a person generates nearly 5 pounds of, say, municipal solid waste per day. EPA also reports municipal solid waste as the third largest source of human-related methane emissions in the U.S., making landfills not just a waste problem, but a significant and overlooked climate liability. So instead of treating waste as a liability, our guest today is building a targeted remediation system that addresses overlooked gaps in agriculture, environmental cleanup, and municipal waste management, converting methane risks and material inefficiencies into cleaner outcomes. So this includes everything from taking, say, the grains that help make your favorite beer and turning it into material that contributes to sustainable food production, to even pulverizing avocado pits to turn it into feedstock. It's really cool stuff. But before we dive further, I'm your guest host, Luis De Leon. I'm a senior public relations account executive at the award-winning tech PR firm Technica Communications, which is led by your main show host, Lisa Ann Pinkerton. Before that, I worked as a broadcast journalist, contributing to award-winning reporting across the country in cities like Milwaukee, Austin, and Denver. Now, whether this is your first or 50th episode, welcome. We are excited to have you here. Be sure to check out our listener survey and Substack newsletter in the show notes. Share the show with a friend, because it's the best way to help the show grow. And thank you to Resource Labs for having us on the network. So today's Tech Spotlight features ADAR Technologies, a company innovating how waste is managed and reused into new materials through their cutting-edge acoustic dehydration technology. It's really cool stuff, so stick around. As an example, the ADAR Tech can convert municipal solid waste into livestock feed or fertilizer, or transform large chunks of seafood waste, like the shells of oysters or shrimp, into smaller and more manageable portions. Heck, they even work on reducing the moisture from fruits to reduce the weight and volume. The list goes on. They have tested this on numerous different types of waste. So here to talk more about their technology and how it works and other use cases in reducing this waste is CEO Dan Kelly. Dan is a multi-exit founder and hands-on operator with more than 15 years of experience building scalable, performance-driven organizations. And get this, he actually began his career with the FBI before switching gears to found companies like The Negotiator Guru and GSD Fuel. Dan, you have such a wide range of experience here, so I'm super excited to get into it. Welcome to the show.
Appreciate it, Luis. Thanks for having me. I'm excited to talk about this.
Absolutely. So I gave you a little intro there, but really, how did you switch gears from the FBI into, I guess, the world of business, and really, how did it come about for you with ADAR Technologies?
My passion in clean tech was really started actually in the FBI, based on some of my work within the Department of Energy. And ultimately, it was just more personal curiosity than anything related to new energy sources. And of course, it included nuclear, but it was also other things as well. And so that's where it actually all started. And then I've had some success in my entrepreneurial journey, and I'm lucky enough to have that success. My first business out of the bureau was actually a private investigative firm, and I focusing on supply chain fraud. And this actually further brought me into the clean energy space, because unfortunately, there has been a lot of fraud within this space historically on government grants, etc. And so that has largely been cleaned up now. But just you asked how it all started. That's how it all started for me. And after one of my first exits, I've deployed quite a bit of capital in this space, and I've shared that I'm a capitalist with a purpose. I'm not a tree hugger, but I believe that the only way for the economy truly to embrace sustainable practices is, quite frankly, for the entire supply chain to be more profitable as a result. And that is what parlayed me into technologies like ADAR, is because we ultimately make the private sector more profitable by also making the right choices. And that is the step change in which is required for the economy to move here. It's not purely relying on government grants. It's not purely relying on anything from a legislative perspective. It has to do with the bottom line. And when we can get the CEOs of large manufacturing companies to understand that they can optimize the middle of the balance sheet by introducing new technologies to help with the bottom, that's how we make a step change.
Sentiment there is something I have heard time and time again, especially with the clients that I work at Technica, including the chief marketing officer of a solar tech manufacturer, as well as a commercial EV charging company. Both of them have said that exact thing. These next few years especially are going to depend on the businesses that can really get outside of government incentive dependency and really focus on how to, I suppose, right size their business with real world market demand and everything. And so I bring that up because it seems like you've really been able to collect a lot of your different perspectives from the FBI, from the other companies that you've been able to either invest in or start, and really bring it all together. It seems like ADAR for you is kind of like this encompassing like end all be all from your past experience. Is that fair to say?
It's a very fair statement. This is the big one, as I call it, right? I've made a lot of money in other things, but quite frankly, I was never fully passionate about them. This one I'm fully passionate about because we are making a seismic difference, and quite frankly, we can be profitable as a result. And when those two work streams of thought converge and work in harmony, that's what matters.
Yeah, absolutely. You can really go into multiple different directions. So I'm sure you have to kind of sometimes like take a step back and really try and focus on like, what are our main demand drivers right now? But before we get, I suppose, like further into it, what is it about those waste streams that you were just kind of mentioning there that present an economic opportunity for more sustainable waste management?
Sure, absolutely. Let me talk about, which might seem a little odd, but let me talk about the worst case scenario and why someone would use ADAR. So the worst case scenario for someone to use our technology is for someone to throw away something cheaper. Now, of course, this is not our objective. Our objective is to create circular economies where ultimately there's a 0% impact. And the net effect is, quite frankly, we're carbon negative, which is the vast majority of our use cases that we engage. But I'm going to describe the worst case first because it's important for people to have this foundational understanding. The primary use cases that we have started with in our R&D journey were those in which had extremely high moisture content. The bottom line is 70 to 90% of the weight of a lot of these feedstocks, like if we think about manure, or we think about seafood waste, or we think about sludge, these type of areas, those are water. And what we're doing is that the transportation industry is transporting water to throw away into the landfills. And when a company goes to a landfill, they pay a thing called a tipping fee. Some people might not know this, but basically it's just a usage fee based on the weight that they're throwing into the landfill. Well, the original premise was, how do we just eliminate the water weight from the underlying feedstock so that we turn everything into a powder? So at the end of the day, we save 75 to 80% of costs just for companies to throw away something. And so ultimately, our technology does three things really, really well. We dry, which is what I just talked about. We pulverize, which means make it into a powder of consistent particle size. And we sanitize. So we eliminate all the mold, mildew, and bacteria and other harmful chemicals within the underlying feedstock. And so again, the worst case scenario, we literally just take away the water weight. We put everything into a powder so that someone can throw away something cheaper. But the real end goal is actually to turn that waste expense, and we talked about the middle of the balance sheet, right? We take that waste expense for these companies and turn it into a revenue stream. And that is where most of our demand is coming from. We get about 5 to 10 leads a week organically, people reaching out to us. And ultimately, this is just a profitability play for them. So they take the side streams and the byproducts of something that they're making, which is essentially like a waste stream off of that product. And they're trying to figure out ways in which we can ultimately just make more money from it versus using it as an expense. And so we focus on those areas in which have high disposal costs so that we can convert those into net new revenue opportunities.
Before we get into like the huge like rundown of the technology from step A to Z, can you give us a background real quick on ADAR's status as a company right now? Like where are you guys? How many employees? If you can give us a rundown here.
The company was started in 2022. We are on our 5th generation device now. And so the first 2 generations were largely what I'd call a tabletop unit, stuff that we put together with duct tape and screws in our garages type of thing, right? Actually in a basement, to be very specific, but the concept's the same. And we've created multiple iterations of this machinery. And long story short, Gen 3, our 3rd generation device, was our key enabler and our key R&D machine. And that is what we have thrown over 100 different feedstocks into. And this was never intended to be sold. It was simply intended for us to figure out what happens. Of course, our engineering team, et cetera, had a field day and a blast with this because we get all sorts of different requests from all over the world, right? And so we've tested over 100 different materials in the machine, and they've all been successful in their own way. And that's what's so exciting about it as well. But also brings, from a executive perspective, the need for focus on those areas in which we can create the greatest impact. So anyway, Gen 3 is where we really started everything. Gen 4 is actually what we've sold into the market. We've actually commercially sold this product into the market, specifically to Europe. And Gen 5, where we are now, is we actually have a U.S. R&D center, as well as a European R&D center. And the Gen 5 is actually 2 different products now that we have depending on the use case.
Are you able to share where in the U.S. and Europe the R&D centers are?
We have an R&D center in Michigan, and then we also have one in the Netherlands, but that's going to be moved to Portugal soon. We've been asked by Ireland to set up our European operations in Ireland legally, but we're going to have operations in Portugal.
So at those R&D centers, we said that we're on Gen 5 here now for ADAR's technology. Can you give us a rundown of how it works?
On the public sector side, people might not think about this just every day, but it's actually local municipalities. It's the people that handle your city trash to the environmental cleanup, the Parks and Rec Board. And so that's on the public sector side. On the private sector side, it's large food producers is a real easy one, again. And these are creating multiple side and byproducts that ultimately we can eliminate the moisture from and create a high nutrient superfood for both animals and people. And so depending on what the customer looks like, we have 2 different approaches to our products. One is our flagship model is actually a containerized unit. So think a shipping container, right? Everything operates inside of a shipping container, and it's up to the customer and how they feed the material in. You'd have stuff feeding into the machine, and out comes a fine powder that is to the specific particle size and to the specific moisture content that the customer is looking for based on their upcycling opportunity. Okay. And so that's a shipping container. Now, part of our Gen 5 development as well is we've actually now created a product that can easily integrate into large process operations. Think of a Cargill, think of a PepsiCo, think of creating Lay's potato chips. Think of these large supply chain production lines that we can't handle in a batch manner. But what they both do is they both use acoustic shock waves. And acoustic shock waves is essentially when the same thing as when an F-16 fighter jet breaks the sound barrier. and you hear this massive sonic boom. There's a water vapor cone that forms on the backside of that F-16 fighter jet. And what's happening is we're actually separating the compound from the water molecule. And so we're actually ripping the water molecule off at a cellular level. And this is what's really important for people to understand who are kind of my techies in the audience here. We're literally ripping that water molecule off of the underlying compound in which what you're trying to keep. But we're doing so in a way in that we're not impacting that compound in which you're trying to keep, meaning we retain all of the nutrient value. And why do we retain nutrient value? Because we're not using heat, because this is purely a natural principle that we find in nature, acoustic shock waves. But ultimately, we're using cavitation, and people generally understand what that is, and which is basically a rhythmic uses of shock waves to create a breakdown and an explosion of that material. And so that's what's happening. We're using acoustic shock waves to create a massive amount of pressure in a short constricted airspace. And the only moving piece in our entire system is actually the jet engine itself, which typically can be very loud, which is one of the reasons we put it in the container, by the way. And so that's the only moving piece in our entire system is actually the turbine. We call it in the US, and Europe you more call it a ventilator or a fan. It's all the same thing. But we have a very specialized equipment in here that's creating massive amounts of pressure in a very constricted space, which is creating acoustic shock waves. And so we're literally breaking the sound barrier inside of a shipping container. And so people ask me automatically, well, isn't this dangerous? Can you blow it up or anything? No, it's not dangerous. What would be dangerous is you've put your arm right directly in the turbine, of course, but there's all sorts of safety protocols in which doesn't allow that to happen. So ultimately, we're speeding up air to the speed of sound, breaking the sound barrier, and then we're inserting material into that airflow. That's what's different here. And that is what's creating our effect.
How long does it take then for that process to take place? I know that there's like all sorts of different types of loads that it could probably take, and that's always going to vary in time. But I guess what could a customer typically expect if they're trying to leverage your guys' product here?
Yeah, for sure. I'll answer that in a couple different ways. The feedstock itself is be moving at 800 miles an hour through the system. So we're literally talking about a millisecond here. Right? I mean, it's literally just running through the machine that quickly. And the ultimate outcome is we have a return feed in here as well, is that if our customer wants it at a specific particle size on a micron level, or a moisture content that's lower than what we initially create with that cavitation, the shock waves, we'll just route it through again, all automatic, all with a Siemens controller, literally a touch screen. It's made for dummies, if you will. You know, those executives like me that can even handle it. So that's what it is. From a throughput perspective, people ask us all the time, what does our R&D roadmap look like? Well, to be very frank, we've been intimately focused on increasing throughput. And the reason for that is because when we can increase throughput, it makes it more profitable for our customers. Meaning they have to buy less of our machines, even though they're modular and you can stick them next to each other. That's fine. But ultimately, we're increasing profitability for our customer. That's the number one goal. And so we've been focused on throughput. And our evolution has got us from basically 1 US ton an hour of input up to 10 or 20 US tons an hour of input material. And that is a seismic shift. For anyone that's in the material processing space will understand that. And so we even have a single or double core unit. So we have different configurations ultimately to maximize that throughput. But the beauty of it all is that the output doesn't change. We just add more horsepower to the system to answer our customers' needs. And that's what's so exciting about this.
What do you think surprised you the most then during that R&D process, considering you all are on Gen 5 now?
What actually surprised me the most is two things. I'll give you a short little story. The first time that I actually experienced this technology, we were processing raw shrimp. Actually, the head and the husks of shrimp. So people ask me about use cases all the time. This is a good one. Head and husks are something you don't eat. You know, when you buy shrimp at the restaurant, you just eat the body, not the head and the husk. Well, that's a waste material. But there's huge amount of protein and nutrition in there to create a nutraceutical process. But the problem is that thing stinks. So imagine going into a bin and a tote of old seafood that's been sitting there for weeks. Just put that in as a visual, right? And how it just absolutely reeks. And I was about to hop on Delta Airlines later that evening to go back home. I'm like, oh my gosh, what am I doing? No, they're not even going to let me on the plane, with me touching the output material here, right? What surprised me the most, actually, might sound kind of funny, but we eliminate the odor. And for people to think about it, it's actually understood. I just wasn't thinking about it at the time because the odor is stuck in the water molecule, which is the same area where the bacteria and all the harmful chemicals are. And so out comes a beautiful, high nutritious powder that can be used for upcycling that is odor free. And so immediately when I got into my head in this, I'm like, think about all of the massive problems, even in the US, that we're having at a municipal level in the agriculture sector. Think hog farms, think cattle yards, think municipal waste that just stinks. Anyway, we create literally an odorless product, but it maintains all the nutrient value. And we have tested literally some of the worst. And was one of the things that we don't talk about enough, actually, is that it's odorless. So that surprised me. The other thing that surprised me is the only thing that doesn't work in our machine to pulverize is metal. Sometimes we say, well, the only use case that failed was metal. Well, no, actually it's a win in and of itself because we pulverize everything around that metal. And so you think of a use case, we're talking about the mining industry now. We're talking about rare earths. We're talking about precious metals like gold, silver, etc. And mine tailings, the piles and piles of mine tailings that are waste products of mining, that the only way to get access to that precious metal inside of these small chunks of ore is to, quite frankly, use chemicals, which is horribly expensive and even worse, horrible for the environment. Instead, you could use our machine and pulverize everything around that precious metal and just filter out what you're trying to achieve. So those were my big aha moments.
We talk a lot about the business impact. I know that's kind of been like the number one priority. But talk a little bit about, what's the sustainability impact here? How is this promoting more sustainable practices when it's traditionally a big polluter?
Sure. So ultimately, we're saving companies 70% in cost typically, and this is just an energy use. And what I want to just share with the audience here is, why is that? Well, the key difference that I didn't mention before in the episode is that we're purely electric. So this is just pure electricity. The reason that we say we're up to 70% more efficient, purely just on an energy basis, is traditional drying in the market uses thermal energy. Thermal energy uses massive amounts of fossil fuels to create that heat. It's flame, right? And so this is why I'm saying we're a disruption to that space, because ultimately the Department of Energy has indicated that between 10 to 25% of the total industrial energy consumption is purely based on drying. I'm going to repeat that again. 10 to 25% of energy use is drying. And this is why ADAR is not a incremental efficiency improvement. It's a displacement at the process layer, because we are enabling an opportunity, even if we took 2 or 3% of that 25%, in which this is a huge mover, right? And it starts with big industry. Where's the biggest polluters happening? And it's also in the industrials. It's also with people that are creating cement. Huge problem. We could talk for hours on this, of course, right? So to answer your question directly, that's why it matters. Not only are we saving money on the input of energy cost, but we're eliminating landfill impact, and we're upcycling these opportunities into something that can be used for creation of superfoods or even sustainable aviation fuels, specifically out of seaweed. That's something really cool we're doing down in Florida and elsewhere.
Your passion here is going to be taken differently depending on where you are, right? And so why I bring that up is, you have your R&D center in the US and in Europe. What would you say are the biggest differences right now in deploying your type of technology? What are some of the differences in the barriers, perhaps, or challenges that you see? Do those different markets have anything to do with the deployment level, or does it really just come down to business acumen at that point?
I will tell you, we don't have a demand problem. And that's what if I could just speak very openly, that's what validates this entire business for me every single day, is the fact that the market is asking for this, not us pushing it. So it's a pull versus a push. The friction is we are literally changing the way companies think about their side streams or their waste streams and thinking about what we can do with it. And that requires some conversations, and it extends the sales cycle a little bit longer than normal at the front side. And it's more on that effect than anything. And at the end of the day, people have historically wanted to test their own materials, which is why our R&D and testing centers are so critical and a necessary evil at the beginning. And so we have a backlog of testing over 60 different companies that are basically lining up to do paid tests with us to see the outcome. And because, again, I get it. Sometimes it feels too good to be true, and it looks and feels like a first-of-a-kind technology. Totally get it. And this is why, from a business strategy perspective, we are turning into a house of brands. Remember what I said, the tech doesn't change inside, but the outcome and the value is. And so ultimately, we're going to be ADAR manure. We're going to be ADAR grape, ADAR bop, right? Again, because it makes the messaging more simple. And so that's the strategy and that's the focus, is getting an anchor customer per use case and letting it expand from there. And letting that anchor customer be part of the journey with us from a commercial perspective and investment perspective. And that's why I'm actually opening up the Series A on this very topic, is because I'm looking for anchor customers on a per use case basis in addition to those customers that we already have.
Certainly seems like a lot of skepticism that you need to overcome, and really like the proof of concept needs to is what you need to really like illustrate for these potential customers. What, you talked about maybe some of the safety skepticism, maybe some of the too good to be true messaging that you might hear. Have you seen prospective customers be surprised by the outcome, or is there any particular piece of skepticism that they're like, oh, okay?
Every time. And that's the aha wow moment that makes it so fun. What people are actually most surprised on is the nutrient value retention, because what people understand is traditional industrial dryers. Think about drum dryers. Think about spray dryers. These are massive, hugely expensive pieces of capital equipment just to buy, by the way. We're a fraction of the price, okay, but that's besides the point. So people understand thermal heat, and I don't blame them, because it's what they've been doing for 100 years. And they understand that you can kind of get the same outcome with 3 or 4 different pieces of technology, but nobody understands how you can do it all with one technology and without using heat. And this even goes into a regulatory play as well. When we talk about sanitizing and neutralizing bacteria, even governments don't understand this in Europe, that to be clear. So we're educating the European Union on this. That's one of the headwinds, is that it's just, quite frankly, an education campaign.
Looking ahead 5 to 10 years, where do you think sustainable waste management and resources recovery will progress? What needs to happen for it to progress, other than, of course, ADAR Technologies efforts?
Well, it's not just ADAR. I mean, this is a team approach. Of course, my commercial focus is on making ADAR as successful as possible for our shareholders and stakeholders. But ultimately, there needs to be a understanding at the industry level that, quite frankly, there are different ways to upcycle without relying on government grants and without relying on carbon credits, without relying on ultimately just to organically make more money. And that has to start at the industry level with the greatest impact. And that is where we're focusing, and that's the conversations we're having. It's where our customers are coming from. And so, quite frankly, we just need more time. And again, it's not just ADAR, it's the entire industry that are creating upcycling opportunities. And that's what it needs.
Well, Dan, we wish you the best of luck on your Series A fundraising here. We're going to be definitely keeping a close eye on you guys and all the different types of, I suppose, solutions that really come out of your product here. So thank you so much again for taking the time and sharing your story with us.
You're welcome, and thank you for having me. And I look forward to anyone that wants to talk about this further. Feel free to reach out to me. Ultimately, we allow our customers to innovate from their waste streams, and I'm excited about it. So thanks for having me.
Awesome. We're excited about it too. And thank you, Earthlings, for joining us on another episode today. We will see you on another turn of this beautiful blue-green space flower that we call home. Primary financial and production support for Earthlings 2.0 comes from Technica Communications, an award-winning PR firm amplifying breakthrough technologies of the future. Additional supporters include Align Climate Capital, who is accelerating the clean energy transition by investing in companies that are developing and deploying proven clean energy technology. Forterra, a pioneering green cement manufacturer developing innovative technologies to produce low-carbon cement. And Green Lane, who is working to build a nationwide network of commercial EV charging infrastructure. And of course, our heartfelt gratitude goes out to you, our listeners and fellow Earthlings, for your curiosity and dedication to showing up for us every week. If you have a topic that you'd like us to cover, or if you would like to participate in our Pay It Forward guest model, please contact us at lisaann@earthlingspodcast.com, and you can search our entire archive on any podcast app as well as YouTube. So until next time, keep exploring and caring for this beautiful blue-green space flower that we call home.